All right, properties of logarithms. So first thing is we had log of a of 1 is always equal to 0. Log of a, log base a of a is 1. If you had a and you raise it to the power of log of a, and then you have this m, it would be equal. So you're saying log of m with the base of a. So the a's match. It's going to be the answer. It's going to be m. All right. So right here, if we had log base a of a, and then this a is raised to the r power, it's going to be equal to r. ln of 1 is 0. So really, if you look, these two are very similar. It's just kind of a specific case, but really and truly, this would fit in this log of a, log base a of 1 as well, just a specific one, a specific base. ln of e is 1. Same argument, but these two going together. ln of e raised to the r power, it goes back to the one above that, so it's also 1, or r, I'm sorry. And then if you had e to the ln of a raised to the x power, it's going to be equal to a to the x power. All right, here's a few more properties. If you had log base a of m times n, so it's a product. You guys remember this? You can take your log and you can actually split it up. And it becomes product. So log of base a, m and n multiplied together is log base a of m plus log base a of n. So it's just addition when you multiply. Now when you divide, you actually subtract them. So log base a of m minus log base a of n. And the other property we use quite often is when we have an exponent, we can actually take that exponent and move it to the front. So it's r log base of m, so r times log base a of m. All right. The other thing we can do is pretty nice, and it comes in helpful for us, is we could take our logarithms and we can do our change of base formula. So I'll just write it this way. So if you have like log, I'm going to say b, so base b of m over log base a of m, or sorry, b. So you could actually change these bases to whatever you want. As long as, obviously, they can't be negatives, can't be 0, can't be 1, but anything above 1, you can change these bases to. That's what we typically use. And I rewrote this, I'm sorry. Let me fix that real quick. I'll just rewrite it right here so you can see it. Kind of had it messed up. I apologize. So it's log any base you want of m, log of any base you want of a. Now the a is right there. So this m moved to here, and the a that we had as a base is actually moved now to there. And we can change the base to whatever you want, like I said before. Now over here, this is just kind of be redundant, but just to make sure you understand that it can work this way as well, you could use natural logs and just say ln of m over ln of a. It's a specific base e. Okay, now we're going to use our properties to find the exact values of these logarithms. So the first one, if you just have to lose all these different ones we had up here before, you recognize that 2 to the power of log base 2 of pi is just pi. If we had this one, log of 0.2 with base at 0.2 raised to this negative root 2, it's just going to be negative root 2. And then if you had ln of e to the kt, it's just going to be equal to kt. And I'll go ahead and write this one. It goes along with the other properties above, but just to kind of show another way of thinking about it, we could take this kt and move it to the front. Then you have ln of e. Well, ln of e is equal to 1, right? So that's why it's just kt times 1. That's another way of thinking about it. Okay, next set of instructions is write these as sum and differences. So I'm going to go ahead and just go all the way through all of them because it's good practice, and you just understand that there could be multiple answers on this depending on if it's multiple choice. So I just rewrote this. That's the same thing as log base 2 of x plus log base 2 of the square root of x squared plus 1. Because remember, when there's a product within our logarithms, we can actually rewrite those as two separate logarithms, and we're going to have a sum in between now, so plus. There's not really much we can do with this log base 2 of x. It's already taken care of, but we could rewrite this other one as x squared plus 1 in parentheses raised to the 1/2 power. And then, like I said, well, let me finish this out. You can move that exponent to the front. So it's just now 1/2 log base 2 of x squared plus 1. And just understand that any one of these three could pop up as an answer choice. So I just wanted to make sure I wrote all three of them. So if you were looking at a multiple choice type question, you could understand that any one of these three would potentially work as an answer. All right, the next one. Just rewrite it again. So you have x squared over x minus 1 cubed. That's the same thing as ln of x squared minus now because it's division. ln of x minus 1 cubed. And then both of these have exponents. So we can write those in the front. So 2 times ln of x minus 3 times ln of x minus 1. Part C, it's division. So we can say log base a of the square root of x squared plus 1 minus log base a, let's see what it is again, x cubed times x plus 1 to the 4th. So we could take the first part, I'm just going to rewrite it for the moment. And then we have this, and I'll just say, and we're subtracting that entire portion off right there. So I'm going to put brackets on it for the moment, just to kind of help us out a little bit. So log base a of x cubed, and this is a product. And maybe if I put a parentheses, if that helped you to see it, we could. It's just a product now, so it means we can separate them with addition. So log base a of x plus 1 to the 4th. And now that I wrote it in parentheses, you probably see that's why I did it this way. To understand, we did take this negative and distribute it. So I'm going to go ahead and rewrite the x squared plus 1 also with a 1/2. And then we have minus log base a of x cubed. And then minus log base a of x plus 1 to the 4th power. And so our last step is we could take those exponents and move them to the front. And then we have minus 3 log base a of x, and then minus 4 log base a of x plus 1. So there's our final step we can take on that problem. Okay, now we're going to go backwards. We're going to take these and rewrite them as one logarithm, so bring them together. So this would be the same thing as log base a of 7 plus log base a of 3 to the 4th. Because they're just taking this exponent, moving it back up, or this coefficient, moving it back up as an exponent. Would that be log base a of 7 plus log base a of 3 to the 4th is 81. So we could say log base a of, well, it's addition. So if we wrote it as one logarithm, it would become a product. So 7 times 81. So we could rewrite this as log base a of, what is that, 567. All right, our next one. This is the same thing as ln of 8 to the 2/3 power. minus ln of, well, 5 squared minus 1 is what, 24. Well, ln of 8 to the 2/3 power. Well, the cube root of 8 is 2, and then 2 squared is 4. So it's just ln of 4 minus ln of 24, which is the same thing as the ln of, with subtraction. So we can end up dividing these. So ln of 1/6. All right, next one, log of x plus log of 9. We could just change that to log of 9x. Then I'm going to bring down everything else that I haven't used yet. Now we can take this same exact product, or this sum rather, and make it a product. So log of 9x times x squared plus 1 minus log of 5. And then our last one, we have a subtraction. So log of, we have all that stuff in the top, all over 5. In this section, we're going to simplify everything. So first one, log base 8 of 2 plus log base 8 of 4. We can rewrite that as one logarithm. Base 8 of, will end up being 2 times 4, which is log base 8 of 8, which means we're equal to 1. So log base 8 of 8 is equal to 1. On this one, we can have our part B. Make sure we're not getting confused here. You can write that as log, or 3 rather, raised to the power of log base 3. And since it's subtraction, we could write it as 5/4. And then we know that these 3 and this log of 3 are going to simplify just to this part that's left over right here inside our logarithm. So 5/4 will be our answer on that problem. All right, our final one here on the simplify section. Log base 2 of 6 times log base 6 of 8. See a lot of 2's and 6's here, so going to be a little bit strategic on this, and we're going to rewrite these, change a base formula. We haven't done that yet, I don't believe. So I'm going to rewrite this as log base 2 of 6 over log base 2 of 2. And just to make sure you understand where all that stuff went, this 6, okay, and our change of base is now right here. You can see that. And then this little 2 right here, this base 2, is now rewritten right here. And then remember, we can rewrite those bases whatever we want them to be. I want them to be 2's in this particular problem. And I think you'll see why I did that way here momentarily. So now we're over here, we're going to go log, again, base 2 of 8, and then log base 2 of 6. Well, you can see that this log base 2 of 6 and this log base 2 of 6 will actually simplify into 1's. So we're left with log base 2 of 8 over log base 2 of 2. Well, log base 2 of 8, 2 to the 3rd power would be this 8, so that's 3. Then log base 2 of 2 is 1, so we're equal to 3 in this particular problem. Our last section, we're going to express y as a function of x, with c understood to be as a positive number. So first thing is we have ln of y. We're going to combine everything on the right side. It's all addition, so we can write this as one big product. So we'll just go ln of, well, the c is a constant, it's a positive number. You can go just write it in the front with the x as a base, and we're multiplying those together. And then we have our x plus 1 left in parentheses. So that all comes together. And then I'm going to go ahead and do it this way first. Then we'll talk about what happened here. Remember, this is base e. So we could say e raised to ln of cx times x plus 1, just using some properties we learned last unit or last lesson, is equal to y. And then we know that if we have e raised to the ln right here, since this is a base of e, that we can just rewrite what's inside the logarithm. So cx times x plus 1 is equal to our function. So that'd be our answer. So you probably noticed already that when you got to this line right here, we'll make sure right here in this part, we could have just dropped our ln's because they're on both sides of the equation. So you can quote unquote drop them, leaving us just with the y and the cx times x plus 1. But I want to make sure that instead of just going from here to here and skipping this step in the middle, that you guys saw why that works the way it does. All right, final problem. We can take this and make it as, remember this is base e, so we're going to say e raised to the power of 5x plus ln of c is equal to y plus 4. And then we could say, well, if we're taking e to the 5x plus ln of c, and we're adding within that exponent, remember that's the same thing as just saying e to the 5x times e to the ln of c, because when we have the same base, we add their exponents, so we just split it apart. E to the ln of c, well, remember e and ln would quote unquote cancel, I guess you could say that. So it just become times our constant c is equal to y plus 4. I'm going to rewrite that c as a coefficient, so c e to the 5x, and then subtract our 4 over, and that's what our function y is equal to. So there are two solutions. I will say that this about these two problems, and this might be something good for you to do, either your graphing calculator or maybe on Desmos or something like that. It'd be kind of cool for you to go back and look, and probably on Desmos, I'm looking at the first problem. They're both problems really. And as long as your constant's greater than 0, you can just pick any number you want, plug this in, and see what the graph produces. And then go back and plug this final result that you had and see what the graph produces and see, why are these not the exact same? All right, and then do the same thing for this one. Plug that initial part in along with our equation and see if they are the same. And if they're not, see if you can understand why they might not. For our purposes, this is good enough for right now, but it's just a good little extension and looking into these problems. If you guys need help, let me know. Stay out of the trees.